Bom dia a todos e todas. Bem-vindos a mais um seminário do Centro de Informática. Eu sou Sérgio Soares, vice-diretor do Centro de Informática. E hoje a gente recebe para o seminário a professora Carolyn Seaman. A professora Carolyn é professora do Departamento de Informação e Sistemas da Universidade de Maryland. Ela também é a diretora do Centro para Mulheres em Tecnologia da universidade. E a pesquisa dela consiste principalmente de estudos empíricos na engenharia de software. Então hoje a gente vai ouvir a professora Carolyn, que também trabalha bastante com qualidade de software, e ela é formada em computação pela Universidade de Maryland, tem um doutorado em Maryland, e o mestrado na Georgia Tech, e o bacharelado dela no College of Wooster, em Ohio. So, Carolyn, welcome here. Thank you for talking with us today. You have the floor.
Muito obrigada. Muito obrigada a todos por estar aqui com nós. E obrigada pelo convite, Sérgio, para estar aqui. Me sinto bem em casa aqui em CIn. Passei um ano aqui em 2012, 13, 10 anos atrás. E é muito prazer estar aqui outra vez. Muitos amigos meus que estão aqui. Mas desculpe, porque eu falo português estilo norte-americana, que fala espanhol, que está tentando falar português. Então, vou continuar em inglês. Okay, muito bom. Thank you. So thank you again for being here and joining me today. My name is Carolyn Seaman, and Sergio introduced me very nicely. I'm from the University of Maryland, Baltimore County, or UMBC, and I'm going to talk a bit today about something called technical debt, which is what I spend most of my technical research time working on lately. So I'm going to talk a little bit about things I've done in technical debt research, as well as things that I hope to do and hope other people will do. So I'll start out by explaining what technical debt is. It's a research topic. It's a research topic in software engineering, but it is also a phenomenon that happens in software projects all the time. And I'm going to go through some research questions, that we have done a lot of work on and know a lot about. Some other research questions we don't know enough about, that we've done some study, but we need to do more. And then there are some really, really important research questions that we're just beginning to look at. I'm also going to tell you about a few projects that I know about that I'm personally very excited about, that I think are pretty cool. I'll do a little bit of a advertisement for the next Tech Debt conference, and I'll summarize at the end. Okay, so technical debt. So the context in which we talk about technical debt is software maintenance. Okay, so this is the latter stages of the life cycle of a software product. So usually after it's been delivered for the first time, people are using it, its users, its customers are using it, and the developers are maintaining it, evolving it, making changes, tweaking, fixing things, adding things, changing things. And the thing is, in the US, all over the world, here too, there are a lot of big pieces of software that have to be maintained. They're big, they're old, lots of people use them. They're too big and expensive just to replace. So when they become less useful, we have to modify them, okay? So they need constant modification to keep them useful, because it's too hard, too much money, too costly to just replace them. So a lot of money goes into maintenance, into software maintenance, much more than in software development, and it lasts for a longer time. So software development, we're always talking about tight budgets, tight time constraints, and that's even more true in maintenance, because in most organizations, their business model means that customers don't pay for maintenance. They don't get more revenue from maintenance, so there's even fewer resources to spend on maintenance. So what happens a lot in software maintenance is corners are cut. You do a little bit less here, a little bit less here, do just enough to get the next version of the software out the door. And this leads to degraded maintainability. So the software becomes harder to work with, not well structured. So this is technical debt. And the technical debt is a metaphor, okay, with financial debt. So we all know what financial debt is. We go to a bank or somewhere else and we borrow money so that we can do something we want to do right now. And then later we have to pay that money back plus some extra, some interest. Okay, so it's the same idea with technical debt. It's a metaphor. It's not a grand theory. It's not even a scientific concept. It's more a language, a type of language to talk about this phenomenon. So in 2016, there was a Dodgstool seminar on technical debt, and we finally, after many years of trying, came up with a definition. It's not the best definition, but it's a definition. So the definition of technical debt is, in software-intensive systems, technical debt is a design or implementation construct that is expedient in the short term, but sets up a technical context that can make a future change more costly or impossible. Technical debt is a contingent liability whose impact is limited to internal system qualities, primarily maintainability and evolvability. So obviously this was written by a large committee of academics, a lot of big words. So let me break it down a little bit. So first of all, in software-intensive systems, so we're talking about software, not other types of systems, not physical systems, but software. It's a design or implementation construct, which means it's something related to the code. Okay, maybe not the code itself, but something close to the code, something about the architecture or design. It's expedient in the short term, meaning there's some advantage to having technical debt in the short term, okay? But it can make a future change more costly or impossible. And this tension between the short-term benefit and the long-term cost, that's the central concept of technical debt. Just like financial debt, you get something good right now in the short term, it's an advantage, but you pay for it in the long term. So decisions about technical debt always have to weigh that trade-off between short-term and long-term. It says technical debt is a contingent liability, which is just a fancy way of saying short-term gain, long-term cost, limited to internal system qualities, meaning technical debt is mostly invisible to the user. Okay, so we're not talking about bad user interface. We're not talking about bugs. We're not talking about lack of reliability. Those are all issues with software, but technical debt is the internal quality, maintainability. It's the kind of quality that only affects the developers, not the users. So maintainability and evolvability. Okay, so again, it's closely related to the code. It's problems in the code or in code-related artifacts like design. The primary focus is on maintainability as the quality focus. And this short-term versus long-term impact, that's the core of the concept. That's the most important part. So there are benefits to technical debt. They're short-term. You have higher productivity because you're doing less work in the current release, and the current release will cost less and you get it done more quickly. So those are the benefits, which are short-term, but there are costs. So there's what we call the interest, the juros, I think, in Portuguese. So you have to pay this debt back, and it will cost more in the future than it costs now. Okay, so sometimes when I first learned about the concept of technical debt, I learned it from some developers I was looking at, and they literally went like this when they talked about technical debt. I don't know if you can see this on YouTube, but it's a gut reaction. It's something they feel bad about. It is a debt they owe to the system. It's time they should have spent on the system, but they didn't. So it's something they owe the software system. So the metaphor of interest works well. But the other cost of technical debt is a risk that it could get out of control. Some people call it technical bankruptcy. But it's the kind of thing that the software gets so bad and so difficult and so fragile that you have no choice but to replace it. Okay, and that's a risk. All right, so this is what technical debt is. So there's lots of research in technical debt. There's lots of different things that you can ask about technical debt. And technical debt research has been going on for decades, but we've called it something different. Sometimes it's called software decay or software aging. or software evolution. But we've been calling it technical debt for about 12 or 13 years. The first workshop on technical debt was in 2010. And a lot of that work has been done on identifying technical debt. So in the early days when we were naive, we thought, well, the problem is you just have to find these places in the code that are difficult to work with, and you fix them, and you're done. No. Once we started finding technical debt, we realized how much there is. And there's more than is cost effective to fix or to pay back all at once. So the first research question is, how do you find technical debt? And there's a lot of research, in particular in finding tools, things like static analyzers, more sophisticated static analyzers that find more architecture level technical debt. So ton of research on that. There's more we could do, but a lot of technical debt research has been focusing on finding or identifying technical debt. So the harder question is, once you find it, how do you know how important it is? What is the value of technical debt? So what's the value of taking it on? So what is that short-term gain that you get? And what's the value of paying it off later? So this idea of value, it's related to the financial debt metaphor of principal and interest, but it can be more complicated than that. We also want to know which types of debt, of technical debt, really matter. Because there's some, sometimes you have a class, it's full of awful code, it's spaghetti code, it's written horribly, all the variable names are a single character, it's just, nobody understands it. But if nobody ever has to maintain it, if nobody ever has to change it, doesn't matter, okay? So we want to know we need to find a way to identify the debt that really has an impact. That if we change that, if we fix that debt, we really will see a benefit later with less interest. And which types of debt are actually worthwhile to eliminate, worthwhile to pay back. So in financial debt, that's easy. If you have 5 different loans from 5 different banks, and you have the ability to pay off one of those loans, you choose the one with the highest interest rate, right? It may be a little more complicated than that, but that's the idea. You have some numbers that can tell you which loan is the one you should pay off first. Well, we don't have an interest rate for technical debt. It's hard to predict what the interest will be, so it's more complicated. So these are the kinds of research questions about identifying and characterizing technical debt that we still need to look at. So some of the things that we have learned about from the research in technical debt identification is that there are different types. So the design, sometimes called design debt, code debt, architecture debt, that's the kind that's very close to the code, okay? And most of these types of debt you can find with tools, static analysis tools, and more sophisticated tools. There's something called testing debt, which is tests that you didn't run. So software tests, in the current release, you have a set of tests that you want to run before the release goes out the door, but you don't have enough time, so you don't run all of them. That's debt. Defect debt is not defects, okay? Because remember, defects that the user can see, that's not technical debt. But defect debt is when you have a whole lot of little defects that you don't take the time to fix. And it's not the defects that cause the problem, it's the accumulation. They've clog up the system, your testing process, because you keep finding the same little defects over and over. So your testing becomes very inefficient. That's defect debt. And then infrastructure debt, which we're not studying enough, but I'm finding that it's one of the most, in many contexts, it's the most common type of debt, where your software system has layers of infrastructure underneath, an operating system, a database management system, a user interface generation system, etc. All this infrastructure software, which is also being maintained, and new releases come out. And if you don't upgrade to the latest release, eventually your application software on top, there's a mismatch. It doesn't work anymore. And if you wait too long, it's a huge, huge job to upgrade, and then you have to change all your application software. That's the interest for not upgrading a little bit as you go along. So infrastructure debt is another kind. And there are others too. In fact, there's a ton of time spent among academics discussing whether a particular kind of debt is really technical debt, and I won't go into that. But So some debt is easy to find, some is not. What's easy is you know what test cases you didn't run. Okay, if you have a test suite, you have your test results, it's pretty easy to figure out what test cases were not run. Defects that were found but were not fixed, that's easy. Classes that everyone knows are a mess. Okay, in a software project, usually you can ask people which classes, which methods, which packages are really a mess, difficult to maintain, and everybody kind of knows that. What's a little bit harder is code that gradually decays over time, because software is invisible, right? And as the structure, the architecture degrades over time, sometimes you don't really see it. Design patterns. Okay, it's amazingly difficult to keep a design pattern valid over time. You make little changes to the code and all of a sudden your pattern is broken, but you don't realize it, usually. So some things we've done, techniques, tool techniques in particular. So say you have a system and this is the class diagram, and here's a bit of the code and a method. We have things called automatic static analysis tools, or automatic static analyzers, that look at things line by line and tag things like bad variable names, using single letter variable names, or not having comments, or not using exceptions properly in Java, things like that. There are code smells, which are more at the method and the class level. So code smells having methods that are too big, or classes that are too big, or not using inheritance or polymorphism properly, things like that. Then there's grime. So continuing the tradition of having really icky words for this thing, grime is the degradation of design patterns, breaking of design patterns. So the design patterns are nice and pretty when you start, and then they kind of get dirty around the edges. So we call that grime, and we now have tools to detect grime, which we didn't used to. And then modularity violations is an interesting idea. Your architecture of your software, you usually have rules about which components can talk to which other ones. So this component can exchange data with this component, but not this one. But that breaks down a lot of times as developers take shortcuts when they're doing maintenance. And sometimes that's hard to detect. So one strategy we have for finding modularity violations is looking at the change history. So if this module A and module B are not supposed to talk to each other, but you look at their change history and find that they almost always get changed at the same time, then there's a connection there that shouldn't be there. So that's called a modularity violation. My animation is out of order here, but that's the idea. Okay, so those are some things we know about technical debt identification, and lots more stuff that we want to know more about. But the other side of the coin is management. Once you've identified the debt, you have to do something about it. Early on, we thought all we had to do was find it, and then you fix it, and then you're done. Well, we've realized that's not true. There's this whole management part, because there's so much technical debt, you can't just fix it and you're done. So managing technical debt means somehow characterizing how much debt you have, how much principal, how much interest. Sometimes that's measuring, but in a lot of cases, we're not sophisticated enough to measure it. Sometimes we can estimate it. Sometimes we can just characterize it. Say, it's there, it's of this type, this is where it is. And this is trying to get at this idea of value, which is something we're still struggling with. We want to monitor it because the debt changes over time as you make changes to the software. And then the big part is you need to make decisions. Okay, you need to make decisions because a lot of times you're running against a deadline and you have to make a choice between doing something quickly to get it out the door because you know that will increase your technical debt, or pushing the deadline to give you more time so you can make the change without incurring debt. And then once you have the debt, you have to decide when you're going to pay it off. When is the cost-effective time to take it off? So this is decision-making is a big part of the game. So there are a number of studies, usually case studies, some survey studies, that just sort of figure out how do projects do that now? How does industry manage this technical debt implicitly or explicitly? There's been a lot of work on prioritization of technical debt? How do you decide which technical debt is the most important to pay off right now? How can we predict the impact of technical debt? So this is related to prioritization, because if you know for each particular instance of technical debt what its impact will be, what its interest will be, then that helps you prioritize. But we're not very good at that yet. So that's a big one that we need a lot more work on, is prediction. And decision making. Lots of other disciplines in the world have looked at decision making. In fact, there are whole disciplines called decision science or decision support. What methods could we borrow that would work in this context? And this, we haven't done a whole lot, a little bit, but haven't gotten very far in this area. Okay, so that's my overview of the important research questions in technical debt research. Some we've done a lot of work on and we know a lot. Some we're just starting to look at, and some we really need to look at to make progress. But there are a few sort of current and very recent studies and lines of work that I'm very excited about, that I just sort of want to give you an overview of. One is the Insight TD project. So Insight TD started in Brazil at UFPA in Salvador, not UFPA, Unifax in Salvador, by Rodrigo Spinola. And it is basically a survey study. So it's a very carefully crafted survey distributed to software practitioners. And it's a fairly long survey, and it asks a lot of questions about technical debt. And it's structured as a storytelling survey. So it asks developers, it asks the participants to think of one story about technical debt in their experience. And then it asks a lot of questions. What caused that technical debt? What type of technical debt was it? What was the impact? What did you do about it? Did you pay it off? Are you still living with it? What happened? So we ask a lot of questions to get their stories, okay? And then we ask some general questions about, I'm part of this project, and we ask about technical debt in general, the management of technical debt in their organizations, and the size of the organization and the application domain, things like that. So the cool thing about this project is that it's replicated globally. So up till now, I think we have 13 different countries, and each country has a replication team. And they distribute this survey study, and we now have a data set of, I was going to look that up, how many data points? Close to 1,000, I think, maybe 800 data points. So it's a really nice source of data from practice, from industry. And we've analyzed that and sliced and diced the information and published a lot of papers about differences between countries. It turns out that's not so interesting. But the relative importance of different causes and effects of technical debt, okay, and how they match up, and what people do about it. This is particularly interesting. Not only what they do about the technical debt that they know is there, but what they do to try to prevent technical debt. So it's a nice, rich data set. And we've used it to build on, to start some other projects on things like preventive actions. So what kinds of things can you do to prevent certain types of technical debt? We're trying to use it for decision making, trying to figure out how people make decisions about technical debt. And then we have a new project we're starting on education. How do we use this data to develop curriculum to teach particular undergraduate software engineering students about technical debt and how to manage it? So that's Insight TD. It has a website there if you want to learn more. There's been some work on looking at technical debt in startups, which is particularly interesting because technical debt, if you read the literature on startups, and I'm talking particularly about software startups, so it's a startup organization, a new small company, very young, and their main product is a piece of software, an app or something. It's a piece of software that they own and that they sell, and that's their business model. And software startups, when you read the literature, the sort of the case studies on the life and death of startups, really, oftentimes the death can be traced back to technical debt because they have to develop that initial product so quickly, and they accumulate a lot of technical debt because if they don't do it quickly, then they die anyway. So this particular study is done by a recently graduated PhD student of mine, Abdallah Al-Daij, who did a series of case studies. He had 9 interviews in 4 startups, and trying to ask people, what kinds of technical debt came up? What did you do about it? Did you make decisions that you knew were going to cause technical debt, and why? And he distilled that into a set of decision factors and rules. And what's interesting about this study is he not only asked them what they did, but he asked them, in hindsight, what should they have done? Did they make the right decision based on what happened afterwards? So in the end, the model he came up with to put all this together really is a prescriptive model, because every decision that contributes to this model either was the right decision, or we replaced it with the decision that they thought they should have done. So I'll show you just a little piece of it, and you probably can't read this, but the idea is along the bottom is the startup evolution timeline. And this comes, well, part of it comes from the literature. On the very bottom are two of the three stages, startup stages in the literature. There's sort of a stage before going to the market, after going to the market, and then there's a maturity stage, which then you're not a startup anymore. So that's not included in our model. But what we found in our data is that there are these mini stages in between that every single case went through. So that next to the bottom row are the more fine-grained stages, and that's where we found differences in how people dealt with technical debt. So each of these boxes are decisions that were made and should have been made at those different stages. The decision factors are not here. These are just sort of the actions. They're color-coded. The blue ones were decisions to take on technical debt, and you notice those are more towards the left. So the participants in this study really did talk about where they knew they were going to cause a lot of technical debt, but it was worth it because they had to for the business model. And you don't see so much blue on the right? Because as they get closer to maturity, they don't want to take on more technical debt. That's only worthwhile at the beginning. And then the green ones are paying off technical debt, decisions to pay off technical debt. Again, more towards the right. As they get more towards maturity, they have the ability to take some time and pay off that technical debt. And then the gold ones are what they did to prevent technical debt. So it's interesting. I know you can't see a lot here in this picture, but you can read the paper if you like. So this is an example of a study that is really looking at how decision making is done in practice right now. So, which is a beginning step towards doing research on how decisions should be made about technical debt. Another set of studies or an area of research is visualization, which is also geared towards decision making. So the idea of having visualizing technical debt in different ways is to help people make decisions. So, and there are a number of different approaches to visualizing technical debt. And this one I think is particularly interesting. It uses something called a Sankey diagram. So Sankey diagrams, I believe, if I'm correct about this, were developed a long, long time ago to model things that flow, like water and air. And the vertical bars are the different sort of places that water or air or products, actually they're often used to model markets, like the flow of grain or oil or whatever through different places in the market. And the idea is that the flows that go from left to right are bundles of whatever it is you're modeling. In this case, instances of technical debt. Or actually, in this case, it's tasks, software development tasks. So it starts on the left with where these tasks are originated. And the different bars are different parts of the organization. So some of these vertical bars are business units. Some of them are products that are being marketed to a customer. Some of them are technical product teams. So they're different parts of the organization that are affected by the quality of the software product. Okay. Then the color coding, the blue and the yellow are principal and interest. I forget which is which. But the idea is that, say the blue is principal. That's the money that, or the time, the effort that you owe the system. So it starts over here on the left. Something's done at the left that creates some technical debt. And then it flows through and shows how it affects these different parts of the organization. Okay. And then there's this feedback loop, the red line, which is more technical debt. because when you get to the end, sometimes you've created more technical debt. So the technical debt doesn't always flow from before. It gets created new. So the red line is sort of the feedback loop from the activities that created more technical debt. So that's a rough explanation of how to read this. But it's interesting that this work was done by Alexia Pacheco, who is a recently graduated PhD student from the University of Costa Rica. And she works in a very large telecommunications and utility company in Costa Rica, and did a really large case study on this, where she got together project teams who had in the past made decisions about technical debt, had made a decision either to take on technical debt or to pay off technical debt. And she asked them to recreate those decisions and simulate making that decision again, except this time using these visualizations to see if it would help. And her results showed that yes, they said yes, they would have made better decisions if they'd had this type of information and this type of visualization. So this is one example of visualization research in technical debt. Another line of research that I think is just starting, which I think is fascinating, is something called temporal discounting. And the basic idea is that humans, we tend to perceive future benefits as less valuable than immediate benefits. And this is something we know from psychology. Okay? This is not software engineers who thought this up. This comes from psychology. Well, technical debt is all about future benefits and immediate benefits and the trade-off between the two. And that's not the only area in software engineering and software development where those kinds of trade-offs are done. Several people are working on this, Christoph Becker and Fabian Fagerholm. Fabian is in Finland. I think Christoph is in Sweden. They've published several papers on this where they've tried to apply this theory to software engineering. So the idea is that a general human tendency is to discount future benefits. So future benefits in general are less valuable, but there is a lot of variation among different people. So some people are more into what we call delayed gratification. Sometimes we raise our kids that way. Now, if you wait, you can have 2 cookies after dinner, or you can have half a cookie now, that kind of thing. So some of us have parents who were more into that than others. So there's a lot of variation among people, and also situations. There are situations where you are more willing to wait for a future benefit that has more value. So Becker and Fagerholm and others have done a number of different studies that tried to pick this apart. What are the factors that affect temporal discounting in a software engineering context? So software developers and managers who are faced with a decision where they have to weigh future benefits versus immediate benefits, what are the factors that make them place a greater value on the future ones? And how, in particular, how does that affect technical debt management? Because that's a core concept. And how should we design the infrastructure for decision making to take into account this tendency of people to discount future benefits? So this is just work in its infancy, but I think it's really interesting because it takes into account the psychology of human beings, which as software engineering and computing researchers, we like to pretend that doesn't matter, but it does, of course, because software is built by people. But it also, in a sideways way, brings in the business side, because technical debt is very much a socio-technical kind of topic. We have to take into account the business models of software organizations as well as the people who are making these decisions. Okay, like everything else in the world, somebody is trying to apply machine learning to technical debt prioritization. So this is work done by Diogo Pina, who's a PhD student at USP, and his advisor Alfredo Goldman and me. So what Diogo has done is developed a big data set that represents decisions that were made about paying off technical debt. And one of the interesting things about this work is how he got that data set. Like, how do you get a big data set that records whether people decided to pay off or not pay off a particular instance of technical debt? So what he did is he used GitHub. He started with GitHub. He mined GitHub. found a bunch of repositories and developers of hundreds and hundreds of projects of all different kinds, sizes, shapes, colors. And he asked the developers, put out an invitation, would anybody be interested in helping me with this? A lot of them did. And so he set up this survey that matched a particular developer that he was querying with work that they had done on an open source project, and used SonarQube, which is a static analyzer, to find instances of technical debt, so places in the code that should be fixed, and presented that to the developer and said, okay, here, we think this is technical debt, and this is why. What do you think? Is this technical debt? Should it be paid off right away? Should it be paid off soon? Is it okay if this never gets paid off? Or do you think this isn't technical debt at all? So it's just multiple choice. It's code that the person answering the survey was already familiar with. They already knew about it. So they could answer very quickly. And then we had some gamification. So they won prizes if they did a whole bunch of them, which helps to get a lot of data. So we got this big data set of specific instances of technical debt. And then we have lots of metrics from the software that we got from SonarQube, from the static analyzer, about each of those instances. And then we have their answer about how they would prioritize it. So that's the data set he's got. And then he built every kind of machine learning model you could think of using that data set to train and test it. And the answer was all of the different kinds of models. And I'm not an expert in machine learning models, and right now I can't think of a single name of a machine learning approach. But he tried all of them, and they all did really well. Did the usual training versus validation, tenfold, whatever it's called. So tested it in a number of ways, and was getting results for accuracy and precision and recall in the high 80s and 90s percentiles. So that surprised me. I didn't think it would work so well, but it did. So, and this is just an initial cut at it. I'm sure you could do better because the input variables, the independent variables here, were really just software metrics, complexity, code size, things like that, very basic stuff. So I thought that was very interesting. Certainly there is room to grow in there. So those are some things I'm excited about technical debt. Before I stop, I do want to give a little plug for Tech Debt 2023. It's a big sell in Brazil because it's in Australia in 2 months. But if you happen to be in Melbourne, Australia, around the middle of May, you might want to stop in and check out Tech Debt 2023. It's co-located with ICSE. There's the website there. There's a technical track, industry track, and a short paper track. And the Tech Debt community is a fun group of people, too. It's not an enormous community. So we all tend to know each other well, but every year we bring in new people, and it's a good group of people. So, and then the next year I think it will be with ICSE 2024, which is it's in Portugal. Lisbon? Is it Lisbon? Might be slightly more accessible. All right, so I'd like to end with kind of my vision of technical debt research and where these different research questions fit in. So this is how I visualize technical debt. In the middle, there's this box that is technical debt. And there's all these things that you have to do with technical debt. You have to identify it. You have to find out where it is and what kind it is and characterize it. You might want to visualize it. There's lots of different ways to visualize technical debt. You have to assess it in some way, and this is the whole idea of value. What's the principal and interest? But I think we need new ways to think about the value of technical debt. But finally, we have to make decisions about technical debt, about taking on the debt and paying off the debt. So that's all the stuff in the box. But it's also important to look outside the box. What comes before technical debt? What causes it? What are the sequence of events that will lead to technical debt happening? And then what's the impact? Why does it matter? What kinds of bad things happen when you have technical debt? So there are tons of research questions that fit in here. I think Insight TD, the survey, tried to get a little bit of this about because the causes of technical debt are never simple. It's not like this happened on Tuesday and on Thursday we had technical debt. It's not quite like that. So there's a series of things that happen to lead to the context where technical debt happens. And I'd like to understand that better. And that's related to preventive measures. So if there's this chain of things that happen that in the end gives you technical debt, where in that chain is it easiest to cut it off? and prevent the technical debt from happening. I think that would be very interesting. A lot of current research, but there could be more research on tools and techniques for managing technical debt. We've got lots of cool tools for static analysis of code that gives us all kinds of information about technical debt. That's great, but I think we can go beyond that. And this whole idea of value, which is slightly philosophical. So principal and interest, that's kind of what we've been using for the last 10 years, but I think we could do something more. And then there isn't nearly enough on this, and I feel like there should be more work on this, but I'm not doing it either, so I can't complain. But what kinds of technical debt actually cost in the future? There's not a lot of work on that, surprisingly. And then these consequences, these bad things that happen, we don't have good ways of measuring that. We have measures of productivity, and that's usually what we use. So things like velocity in an Agile project. So, productivity goes down when there's a lot of technical debt, but a lot of things happen that make productivity go down. It's hard to isolate the effect of technical debt. So coming up with some metrics that really characterize the consequences of technical debt. So lots of work to do, right? All right, so just to recap, in case you're just joining us, I've been talking about technical debt in software development, and it's a metaphor. It describes a real problem in software engineering practice where not just big old systems, but primarily big old systems get grodier and grodier, get harder to work with as they get older. So there are a bunch of basic research questions I've talked about, mostly focused on identification of technical debt and management of technical debt. And then there are some emerging projects, lines of research that I think are very exciting. There's the Insight TD survey, which is a lot of data that could be mined to answer a number of different questions about causes and effects and measures management strategies for technical debt. Technical debt in startups, I think, is very interesting and very different from other kinds of organizations. Decision-making is the key to making management of technical debt more efficient and effective. And related to that is visualization, new ways to visualize this complex phenomenon in a software system. Temporal discounting, so we understand how people's minds work when they think about technical debt. And then machine learning, because why not? I told you a little bit about my view of the future, my vision of technical debt and research, and you've had an invitation to join the Tech conference. So that is it. Muito obrigada. And are there any questions? Thank you.
So thank you, Carolyn, for the great talk. I wonder if anybody in the audience has a question. So Paulo has the first one.
Okay, thanks, Carolyn. Very nice talk. It's a good opportunity to catch on latest research on technical debt. And so since you talked about machine learning, I was wondering what will be the impact of large language models like in Chat GPT and also GitHub Copilot on technical debt? Are they going to increase technical debt, eliminate it completely, or what?
Wow.
I think we turned the microphone off.
So do I use this, or it's good? Okay, all right. So no, I don't think it will eliminate technical debt. But I don't know. There is, in my own work on technical debt, I do get a little bit torn between how data intensive research on technical debt is or should be, because there is such a human element that defies data. So I think any approach to any aspect of technical debt management will have to be hybrid, in the sense that there's always has to be a human in the loop. And we've automated lots of stuff. All the static analysis tools have gotten very sophisticated, and they're awesome. But it still takes a human to look at that and tell if it's really a problem or not. which I think is the cool thing about this area, right? If everything were purely automated, it would lose its interestingness very quickly. So that's not a very good answer. I don't know is the answer. But it's interesting to watch these emerging areas and how they fit together. So I know I was a little bit flip about machine learning because, there's a million papers machine learning applied to XYZ, but that's what we have to do to find out the extent of this new technology. So it makes sense. Yeah, thanks.
Carolyn, muito obrigado. Many thanks for your talk. Regarding the types of technical debt, I was thinking about a type, probably it already exists, it's called a project debt. Project debt, which would be related to the software project management. So if we a software project, huge debt in the beginning of the project. So mainly if it's executed under a contract. So the cost of the project is $1 million. So this is my project debt at the beginning of the project. I would like to hear about your comments on that, and if there is a relation of that you probably with technical debt. Could you comment on that?
Sure.
Thank you.
Yeah. So I think what you're talking about is expanding the debt metaphor to the entire project life cycle, and you start out with a debt and you gradually pay it off. And when you've paid it off, you have software that you can give. So I think that's related to something. There's a project management approach from a while back called earned value management, which kind of takes that approach. You have what you think the value of the system, which in many cases is what you're going to sell it for, right? The value of the system at the beginning, and you don't have any of that value at the beginning, and you gradually earn bits of that value as you go along, and that's how you plan your software project. So it's the same idea. The idea of earned value management, I think, predates technical debt. In the U.S. government software procurement industry, that's a very common approach. Companies who want to build software for the government have to use earned value management, and their contracts are written in those terms. And there's a whole set of language and terminology around that. So I think that gets at it. As far as related to technical debt, I think it's related because this debt metaphor is so powerful, and we all understand debt. We all, unfortunately, all know what debt is. And it's a really nice way to capture that idea of short-term versus long-term. So I think it's related in that way. I think technical debt is a much smaller concept, more narrow, because technical debt, we're by definition looking at things inside the software. It's not external, it's internal. So we're not looking at what the customer is expecting or what the customer is paying for. The impact of technical debt is on developers and maintainers, and it makes their jobs harder. So it's a subset, I guess, of the bigger view of the entire product as debt. But it's the same thought process, the same metaphor. Yeah, thanks.
Carolyn, thank you for the nice talk. I have maybe a lower level question about the machine learning project that you did. So when you're gathering data, right? I'm not entirely familiar with technical debt, but it seems that is a very subjective concept, and judgment from each developer might have a different judgment. And how do you ensure that the data that you are collecting, or if you have thought about that, is consistent? Because somebody might judge it in one way and the other way, and this might affect how the machine learning prioritization happened or something like that.
Absolutely, it's completely subjective. The data that we're gathering is subjective, but the phenomenon is also subjective because it's always some person making that decision. So what we're collecting is not data about what should happen, but it's what does happen. Again, because it's a large data set, we're hoping that individual variation is kind of smoothed out because of the size of the data set. But in essence, we're not trying to collect data. We're collecting data on practice. We're collecting data of perceptions and opinions of developers and what they do. And what we're asking about is very, very fine grain. So the answers tend to be more accurate in terms of they're telling us what they would do. Whether what they're doing is correct or not is another question. So that's not a goal of ours to get it correct, but it does correctly or accurately reflect what they're doing with the decisions they're making in practice. So yes, so anytime you're collecting subjective information from humans, what you're capturing is the variation among humans, which is our point. So what we're predicting with the models is we're predicting what people will decide. We're not predicting what the right decision is. That's a different question. Yeah.
Hi, Carolyn. Thanks for the talk. So when you started, so for me, it's like maybe the depth metaphor is interesting, but different from the depth that we take from the bank. It's not always clear that we are incurring in depth when programming the software systems. So I was intrigued by the startup work that you did. So you showed that phases, and then there was a column that we are like always. It seems that we can. There's no way other than accumulating technical debt. So is it the case that these people that are working on startups, are they aware that so that they are actually aware and conscious that okay, we know that we are doing it and we just need to be fast and move things and break things and stuff like that, or are they unaware but afterwards they realize?
It's a mix. Sometimes yes, they were very. It depended on how much software development experience they had. In many cases, yes, they said, I made this decision. I knew that it was going to incur technical debt. Sometimes they don't know the term technical debt, but they understood there was going to be a penalty at some point for doing this. And sometimes, no, they didn't realize it till later. So it was a mix. We didn't really keep track of that. Actually, now that I think of it, it would be an interesting question. But it was a mix. But yeah, sometimes it was intentional. They knew they had to get this out quickly, otherwise there was no business model. So, yeah.
There's the term gambiarra, right? You can use it in Portuguese.
It's kind of a
jeito, something like that.
Jeitinho.
Jeitinho.
Yeah, maybe. So actually, we have a couple of questions from YouTube as well. So I'll have the first one, which was the second here, because it's related to what just Leopoldo asked. Maíra Daya asks, what are the main kinds of technical debt that startups should follow and pay?
Okay. So the primary type of technical debt that came up with startups, whether they paid it or not, was infrastructure debt. So, and a lot of it had to do with many startups are looking for a way to get a product up and running quickly. So they often choose frameworks, object-oriented frameworks that they can code up something really, really quickly. And the choice of that framework was the subject of a lot of decision making. And actually one thing that we came up that according to the cases we had, it's more important to choose a framework that your developers are already familiar with, even if it's not the best one. And that came up again and again. So it's one of our decision rules. Early on, choose something your people know. Even if you know you're going to have to change the framework and completely rewrite your system. It's at the very beginning, it's more important to use something you know. So that's one example of infrastructure debt. I'm trying to think of another example. There were things, testing. There was some difference of opinion about testing and whether it was made sense to take shortcuts on testing. But later on, and a lot of it was about the timing. So at what point is it okay to stop a little bit and pay back some of that technical debt? And it was, it had to do with number of customers. Okay, so that was a metric that's not really in the literature. We didn't find it in the literature, but we added it to the model, that they look at number of users. And when that gets to a certain point, we can breathe and take some time and fix stuff. So that was interesting. And the other curve that they look at is the code growth, because there are lots of new code, lots of new stuff. Oh, the users want this. code it now, which means adding 5 more classes or another package or whatever, and so they look at code growth, and when it gets to a certain point that it's just getting too big, nobody understands the whole thing. That's time also to stop and say, okay, we need to refactor and take a look at this. So those were the big takeaways, I think.
So another one is from Hastingo. Why do you think that technical debt always appears in software projects? Do you think that is a good or bad thing?
Well, I'll start with the second part. Is it good or bad? It is both. A little bit of tech. So the original paper that coined the phrase technical debt is from Ward Cunningham in, I want to say 1992. I'm not sure I have that date right. But he said a little bit of technical debt is good for you. Like a little bit of medicine is good for you. A lot of medicine, not so much. So technical debt gives a project some flexibility. Okay, so you're getting close to a deadline, but it's like a little bit of a release valve. You can adjust your adjust your work by taking on technical debt, and that's a good thing, at least for the business side. The problem is when you let it get out of control and you build up too much, and that's where the financial debt metaphor is perfect, because it's really convenient to have a credit card or to be able to get a mortgage. Otherwise, there's lots of things you can't do in life that you want to. But of course, there's a big risk that you let it get out of control. You have to be diligent, be disciplined about paying it off. So it's the same sort of thing. So is it good or bad? Well, is debt good or bad? Same question.
Makes sense. So Rodrigo Rebouças is the next one.
Hi, Rodrigo.
I would ask if she knows about any study relating technical debt management with cognitive bias. Since tech debt is strongly related to human factors, it could be affected by biased decisions.
Ooh. No, I don't. But you could do that, Rodrigo. I mean, the closest thing is the temporal discounting, which does look at human psychology. It's not exactly the same as cognitive bias. Well, it is actually. It is a type of cognitive bias that we are biased against future benefits as compared to short-term benefits. So that's a type of cognitive bias. But I don't think that's what the question is about. But no, the short answer is no. I don't know of anybody who's looked at that. I think it would be interesting.
Maybe the good part of technical debt is researchers who have stuff to do, right?
Yeah, there's lots of stuff
opportunities,
to do.
yeah.
No doubt.
So the last one from YouTube is from Manuel Silveira Neto. And the question is, do architectural tactics can be a way of solving or dealing with technical debts? Architectural techniques.
Yeah, so there has been work done that showed that the most impactful type of technical debt is architectural technical debt, that the degradation, the breaking down of the architecture. So if you've ever been in a software project, you start off with this nice, neat picture that has boxes and arrows, and it just all makes sense and it's wonderful. It's when those arrows get fuzzy and they break, and new arrows go around, and pretty soon it looks pretty bad. That is a type of technical debt, architectural technical debt. There's been quite a lot of research on architectural technical debt, ATD, techniques for finding it as well as techniques for fixing it. So yes, and there have been studies that show that when that type of technical debt exists, it has the most impact on later development and runs the biggest risk of getting out of control.
Nice. So just a follow-up here. Rodrigo is saying that he's looking to showing that there is a good portion of technical debt. That's sometimes good as well. So there is a follow-up here. I'll let you know.
Okay.
So Paulo has another one? Okay.
I was quite impressed by how broad the definition is nowadays, because it's some time I had looked at it, and also the range of techniques and applications that you have developed. So that's quite impressive, I believe. One thing that made me a little bit confused at sometimes during the talk is that it seems that the techniques and the applications, they are quite different depending on the type of technical debt. Okay, so like for example, the technique for the machine learning one, it's kind of prioritizing kind of low level technical depth at the code level, and others are, like decision making and temporal discounting. It seems to be something that you could apply only at a higher level kind of decision. So how do you see that? Is that really true, or?
Yeah, I think it is true. And I think a couple reasons for that. One is that many of the tools we have work at the very low level. The automatic static analyzers go line by line, things like SonarQube, which is probably the tool that's most often used. So our tools tend to drive the questions we ask sometimes. So a lot of times we look at very low level technical debt because it's easy to find. And we can run a tool and we get a whole list of technical debt items. So if we need a database of technical debt items, that's the easiest way to do it. So that focuses a lot of research in that area. On the other hand, when you're talking about decision making, in practice, nobody makes decisions one line at a time, right? You decide, okay, I'm going to refactor this class or maybe this method or package or whatever. So it depends on the context of the research. So if somebody's working on tools or they're working on a purely automated type of solution for some part of the problem, they will tend to focus very much in the small. But if they're doing more like case studies or they have access to industry or talking to actual people about it, they tend to be higher level because that's the way people talk about it in practice. So we do have kind of the both, and I think we need both approaches, and hopefully we'll meet in the middle somewhere because I think both are important.
So we have another question there.
So I'd like to ask you if there's a development pattern that totally avoids those debts.
No.
So is it impossible, or we haven't developed it yet?
Well, I think we haven't developed it yet. I think it is possible, but I don't know that it's worthwhile because technical debt is an important technique that we have to deal with the business side of software. So we take on technical debt usually for economic reasons, not for technical reasons. I think nobody ever says, I can build a better system if I incur technical debt in it. It doesn't work that way. You incur technical debt because you want to meet your cost and your financial and economic goals. So as long as we're not giving away software for free, and as long as software is a business, I think we will still have technical debt, and should, because it's a necessary tool that we have for making software organizations economically viable. So can we find a way to produce software without technical debt? Yeah, I think we probably could, but I don't think that's a good goal. I think a better goal is to realize that we will always have technical debt, and we want to manage it as efficiently as possible.
So maybe the cost to do it is not worth, right? It doesn't
exactly.
That's kind of maybe the question I have, which will be the last one. It's how big of a challenge it is to use the proper metaphor to evaluate the interest. I'm not sure if this is I'm not sure if this is the right road, feasible at all, or if you could make any effort to do that. It makes sense to say, hey, you said like decisions, how to evaluate the interest of decisions, and after identifying technical debt, how to evaluate the amount of it. And when you show the basic research and the emerging ones, there were none of them in that direction. So I'm not sure how big of a challenge and if it's worth trying to do it.
Good question. So there's been some work on trying to evaluate interest, and it tends to use techniques from risk management, where risk is defined as the cost of something happening times the probability that it will happen. So that's been some efforts to evaluate interest are, for example, a class that is really difficult to work with. You try to estimate, okay, how much more time will it take to make a change to that, and how likely is it we'll have to make a change to that class. So that's one example. The new stuff doesn't. I mean, what's been identified as an important research topic is the value, which right now we we mean principal and interest and the trade-off between the two. And it has, I know people are thinking about it. It's kind of a philosophical question first, and we haven't come up with we haven't figured out what to study, I guess, to learn more about the value of technical debt. So that's a nutty problem that we're still working on. No, and I don't know of any work that's really making progress in that area.
Okay, so Carolyn, thank you again so much for this. Really, a lot of questions, right? So thank you again, and see you in the next seminário do Centro de Informática.
Thank you. Thank you very much.